Let me welcome you to the 10th lecture of surface mining technology. In this lecture, we will cover the opening through box cut part 2, part 1 is discussed in the lecture number 9. So, this is you understand that box cut is the first initial cut we are discussing on the same. So, as the requirement, let us discuss the learning background of the required for the surface mining technology course. This is the learning objective of the surface mining technology course, and this is the expectation from a participant who have undergone to the surface mining technology course. After finishing, they should able to deliver these things. These are some of the textbooks and reference books in general for every class. Beforehand we show these slides, and this is the retrospect of the previous lectures. We have already covered up the introductory part, and in introductory part we have covered the general idea about the surface mining, the status of surface mining worldwide. We have discussed the phases of surface mining, we have discussed the stripping ratios, and in last class we have started the opening of surface mines using box cut. So, that is the first mining excavation carried out in the surface mining. So, we have discussed what is box cut, we have discussed how we will decide the location of the box cut, and we have discussed if the box cut is carried out in the hard rock, how the blasting should be carried out in the box cut in the previous lecture. So, in this lecture we have remained the objective is same. So, in this lecture basically we will start the understanding about the size shape of the box cut and the technologies, other technologies required along with the volume calculations. So, as we are discussing, when we are deciding on the excavation system, if it is hard rock, we have discussed that the blasting has to be practiced, but if it is a soft rock, we have to go for the pre-dodging, then the loose soil removal, we have to go for the conservation of the topsoil, and if the blasting is carried out, then the blast fragmented rock mass has to be excavated, and obviously, as it is a box cut, we have to go for the dumping the material outside the mine. Now, the first part is pre-dodging. Pre-dodging is basically defined that the top whatever vegetation cover is there, we have to remove that one. So, because we do not want that the vegetation cover should be mixed with the rocks and soils, and that will remain there because that is hazardous. So, we do not want that. So, whatever is the top vegetable cover and that part has to be removed using the pre-dodging, and that is dumped separately in a particular place. So, once the land is acquired for the mining purpose, pre-dodging before excavation, the pre-dodging of the top surface is carried out to remove any sort of vegetations at the place. Obviously, if there is any structure, those are available, that those are required to be removed from those areas before the excavation will be carried out. After the pre-dodging, the next job which is required is called topsoil removal. Topsoil, where the vegetation is grown, that is considered as the very fertile soil, and this soil has to be restored, has to be conserved, so that that can be used as the top surface when the overburden or non-fertile materials are dumped. Above that, this soil can be used for the future growth of the vegetation. So, what is happening? Suppose this is the earth crust, and say up to this is some vegetation growths are there. So, first we go for dodging this one. first we go for dodging this one, so that this top vegetation cover can be removed. Then this part then up to this part, which is a topsoil, this topsoil part, this has to be taken out and this has to be restored in some place. So, this has to be restored in some place separately. Below this part is rock. So, this is not fertile enough. So, we have to drill it, blast it, make it fragmented. Then what will happen? This part has to be removed. So, suppose this portion of rock material is dumped at this position, and above this we can dump this soil covers and will allow the growth of the vegetation at this place. So, that is the basic idea of this first 3 These are very important, and that has to be practiced, and after that we will go for fragmenting the rock and go for their dumping. So, you can see this is the pre-dodging. The first is pre-dodging and topsoil removal. Then you can see the conservation of the topsoil. The topsoil is dumped here and allows its conservation. This topsoil is dumped at this position and we are allowing its conservation. We are providing the moisture or water, and so that the vegetable growth can be occurred here. Then we go for drilling and blasting. The first drilling and blasting is carried out here. After the blasting of this one, we go for removal of the material and dumping that onto the dumper, and finally, we have completed the excavation of the box cut. So, this whatever material is coming out, we have to dump this some outside area, we have to dump all this excavated material. So, this is a video, you can see this is the topsoil removal and its conservation. You can see this is the pre-dodging is carried out for the removal of the vegetation, and this is the topsoil is being removed and it is conserved here. So, this is the, you can see this is the ground where the mining is proposed. This is the vegetation is removed, topsoil is removed. Now, the box cut formation is started. So, this is the excavation is carried out, this is the ramp is made, and this is the way we are carrying out. Now, the drilling and blasting is started and we have carried out the construction of the box cut at this position. So, gradually it is extended and the machines are working, the ramps are reconstructed. So, all these operations are going on in this place. So, this is the way we carry out. See, when we are carrying out the box cut at this position, you can see the topsoil removal, all this vegetation removal, all this is carried out in the outside also. So, this is the gradually we are carrying it out formation of the box cut, and this is showing the it is box cut means it is not that you are excavating this at one point. Basically, gradually you are excavating the box cut, but the complete area is box cut is called in a sense that the box cut must accommodate a complete mining unit inside it. So, this is the complete mining unit system is established here. So, now let us discuss about the volume of the box cut excavation. What is this? This is the box cut we are considering, and what should be the volume of rock, because the volume has to be accommodated here, and what is the volume of rock we are taking out from this box cut. Now, for understanding this volume of rock, we have to understand the size of the box cut. What is the size of the box cut? The size of the box cut should be sufficient to accommodate the machines. Now, I have already told you accommodating machine means the you have to provide the area to that machine for its operation. That means, if a shovel is working at this position, you have to allow its area so that in which the shovel is working. You have to give a space for the dumpers to stand. You have to give a space for the drill machine to work here. So, all these are the required area to be provided in the bottom of the box cut. So, that means, box cut is the size in which you are accommodating your one typical mining system, one unit mining system in that area. So, whenever you are discussing about the volume to be excavated by a box cut, in that time you are deciding the size of the box cut is such that you are accommodating a list of machineries in that box cut for their operations, plus there is a ramp provided. So, box cut plus you are providing a ramp as the access to the box cut, and that is the volume you have to shift from the box cut to the outside. So, we will calculate this one, and for this calculation we will see how we are carrying out the calculation here. So, this box cut, this figure is I have already shown to you. This is the box cut. As you cannot see the plan view, let us come to a lower size display. So, this is the sectional view, this is the plan view. So, you can have this is showing the slope. So, this is showing the slope. So, if you are taking out each and every point, let us look into this one by one. The first one, this one is basically giving us the idea of this one. You can see this capital B, capital C and this small n m, this is the face we are observing here, which is a slanted face. This is the slanted face. So, this face basically we are observing at this position. So, this is the face we are observing at this position. This part we have already excavated, that means this face is already excavated, this face and this face, lower face, this part is excavated. So, it is, you can see it is basically a prism, and you can easily calculate its volume of the prism using the formula available in the geometry. So, the similar face is available at this position. So, this is that if this is 1, this is 2. So, the volume calculation formula for these are same. Okay. So, this is the volume of this side multiplied with this length is the volume of this one. In a similar way, you can have a volume of this part which is given in 4, that is also another prism, and this slanted face, this m, small m, capital E, capital F and small l. So, this face you are looking at this position, this slanting face, this horizontal this vertical face is already excavated here. Here also the volume formula is known to you. The centrally this is a cube, or you can say the parallelepiped is excavated. You know the formula is the multiplication of all the sides. This is the formula of the volume. This is centrally at this position, and if you look into this small part, which is nothing but a pyramid, typical pyramid, but in this pyramid this is only the vertical surface. So, that means the point capital M small m, capital M small m is the vertical surface. So, rest are like this. So, you can consider, let me redraw it again. So, this is the vertical one and rest are basically the slanting faces, which is the right combinations of this one. So, this is also 1/3 A into H. Okay. So, this is the H, the A is the area of this one, and this one and this one is same, that is for this part, this is the 6, this is 5. So, you can calculate the volume for all this. Let us look into this ramp part now. So, if you are looking into the ramp part, in ramp part, this portion, if you are looking at this, this is divided in 3 parts. One is we are considering this is completely excavated up to this top part first, then whatever additionally available here we have to deduct that one. So, what we have considered in this case, we have considered that the complete ramp is excavated, that means this part and this part is excavated. So, its volume is considered. Again, if you are looking at this, this is a similar, because this part is vertical. So, okay, let me extend this one. This is this face A, B, I, J, and there is a little bit extension here, and we have taken it out like this. So, this is the shape, and you understand this is this area. You have to take the volume of this into this by minus divide by 2, you will get this complete area. So, you have to multiply with this, and if you are divided. So, a half of this parallelepiped is basically the volume of this one, you can calculate in the 7. But actually this face is having, this B part is not excavated, it is excavated only up to small n part. So, above small n is not projected. So, this small n up to this is excavated, you can see here, you can see the small n is the existing one, small b is not excavated, which is small b is somewhere here, which is not excavated, in this figure. So, we have to, this portion volume is not excavated. So, we have to find out the volume of this one. Again this is a pyramid, and this is the capital B is this point, this is the small n, this is the capital N, and this is the A part. So, this is not excavated here. So, that volume we have to calculate, which is nothing but the 1/3 the area of B small n capital N and the height A B. If you are calculating this one, this 8 and 9 are similar, that you have to subtract. So, the total volume can be calculated as the summation of 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, and this 8 and 9 you have to subtract from there, because in 7 you have considered this is excavated, but actually it is not excavated. But if you really think that this volume is not that much significant, so you can deny that one and you can consider up to this is also fair accuracy you will get if you are not considering this one also. So, there is a chance that if you are considering the length and width required, at this position, length and width required at this position is 100 meter by 100 meter. Say we need 100 meter by 100 meter box for operating our machines. This is the size of the box cut we are considering, 100 meter by 100 meter. If this is the size of the box cut we are expecting, then the volume, if we are trying to calculate accurately, then what will be the volume. So, in this problem we have tried to find it out. So, this is the box size, this is the bench height we have decided, and these are the angles. Ramp angle we have considered 1 in 16, that is tan theta. So, we have considered this is the tan theta value, and bench slope angle we have considered 70 degree. So, with these considerations we have determined these values, volume 1, volume 2, volume 3, volume 4, volume 5, volume 6 and volume 7. So, volume 8 you can see it is only 900 cubic meter. So, it is 2000 cubic meter, and altogether I think total is not coming, let me escape from here. So, you have to add okay. So, this is the total volume it has come. So, total volume it has come 1,84,000 meter cube. So, this 2000 meter cube to 1800 meter cube is not significant enough in this. So, you can fairly approximate, it is not comprising even 2% of the even 1%, it is not even 1% of the total area. So, if you are not considering this one, then also you are fairly estimating the total volume of the box cut. Now, next part which is important is that after box cut how we will proceed. So, I am presenting here some hand sketch, so that you can see, say this is the box cut, this is the box cut here. So, you can see this is the box cut. And this is the box. So, this is the box, and you have to then go for, after this box cut you have to gradually extend your pit. So, what you do, initially you extend from this towards this direction. So, you can extend in this direction, and after this extension you can go for the further extension towards this direction and this direction, and then you gradually proceed towards this direction. So, this is in general you are gradually moving or extending your pit, and in this case for all the cases, say this, if you are looking into the sectional view, after this one you will go for drilling this one. So, you will carrying out the holes at this position, and then you are blasting this one. So, it is gradually extending like this way, and you are taking out the material from here through the ramp to the outside. Okay. This is the reverse way I have drawn it. So, if you are considering this, this is the bench, or let me do it here itself. This is the bench. So, you have drilled at this position. So, these are the holes you have made, then you have blasted this one. So, up to this is blasted. So, this portion is blasted, this is the new face, and whatever is the fragmented rock, that rock is taken out through this ramp. So, this is the extension, this extension is further continue, and gradually you are now expanding towards side way, and this is the expansion you have carried out in this way. After this expansion you are moving towards this, and this is the excavation you have to carry it carry here. So, now your excavation will be like this. So, here you will excavate this one. So, it will, so gradually what will happen, from here you are at this position and you are extending to this. So, you have reached at this position, and finally, what will happen, if you are moving it out, then you will go for excavation this one up to this. So, gradually you are moving out towards this direction, and finally, you will come out with a pit like this. This is your first bench. From this your ramp is moving there. This is the second bench you have constructed. So, after the first bench made, you have started your again another opening you have created here. So, this is not called box cut, but this is the box opening for the next bench. So, that is carried out. We have discussed this part in your pit layout, which is discussed in the introductory part. So, this is the extension of the benches after the box cut. So, this is the end of the box cut. We will continue with the next topics in the next class. Thank you.